Hey, hey. Okay, we're on our last unit before summer break. Woo-woo. This should only be like 4 to 5 video lessons long. So pretty quick lesson, pretty quick unit, but honestly, it's some of my favorite stuff, especially in a few days here. It's like my favorite part of algebra. So we're starting polynomials, our polynomial unit. Polynomial, that's how you say that. We're going to start with classifying them, and all that means is we're going to talk about how to name them. So we're naming some polynomials to start it off. So to name this well, we kind of need a chart, 2 charts to refer to. So we're going to create those charts in your notebook, little tables. Your first little chart is going to be about that wide and go 8 rows down. In the top row, write degree. And then for the following rows, you're going to make a skinny column and then a fat column. Okay. Pause the video if you need to. In the skinny column over here, we're going to start with the number 0, followed by 1, 2, 3, 4, 5. And then instead of doing 6, this is going to be weird, but I promise it'll make sense. You're going to write nth. N is any number. That's what that means. Okay. All right. So we're going to fill in the chart and then we're going to use it because right now it's not going to make much sense. So if a polynomial has a degree of 0, it is called a constant. If a polynomial has a degree of 1, it is called linear. We've heard that word before. We've heard both of these words before. A constant is just like a regular number, no variable attached. Linear equations, that's what we've done all year in my class. Linear means straight line. It's a straight line when you graph it. If it has a degree of 2, it's called a quadratic. Quadratic. In a normal school year, we would be doing quadratics the last month of school, but it's not a normal school year. Quadratics, just briefly, are, if you've ever seen it looks like a U almost, it's called a parabola. Instead of graphing a straight line, your line ends up being curved like this. Okay, it's called a quadratic equation. If it has a degree of 3, it's called cubic. And that might sound familiar because we have cubed things recently with exponents. So yeah, 3 is always cube. And then 4th is quartic, Q-U-A-R-T-I-C, quartic. And then anything above that, like above 4, we're just going to say, if it was 5, if the degree was 5, we're just going to say it's a 5th degree. Technically, I think there's a word for it, quintic or something. But after that, 5th degree, 6th degree, 7th degree, and then the n just means any number. So if it had a degree of 17, it would be the 17th degree. So for the nth degree, we just literally say nth degree. Okay. So these first 5, though, constant, linear, quadratic, cubic, quartic, those are good ones for you to kind of memorize, especially the first couple. Okay. So we'll get into what this means. I know I haven't taught you yet, but I still need you to set up another little chart. I'm going to put it over here. This one is 5 rows. In the top row, we're going to write number of terms. And we are going to make a little skinny column on this one as well. Okay, set that up. in that skinny column, we have 1, 2, 3, and then right here, you're going to do 4 with a little plus sign. And what that means is 4 or more. So 4 or any number higher than that. So if a polynomial has one term, and we have heard that word before, combining like terms. If a polynomial has one term only, it's called a monomial. M-O-N-O-M-I-A-L. Mono means one. Monomial. If it has two terms, it's a binomial. Mono means one, bi means two. And then 3 is, hopefully you kind of know it, trinomial. Okay, so I think that has like Latin roots right there. Mono is 1, bi is 2, tri is 3. Yeah. But anything that has 4 or more terms, we just call it a polynomial. So polynomial is kind of like the, I don't know, overarching name. And if it has one, we can be more specific. If it only has one term, you can be more specific and call it a monomial. If it has 2 terms, you can be specific and call it a binomial. 3 terms, trinomial. But overall, it's called a polynomial. And if it has 4 or more terms, then we just call it polynomial. So right here, polynomial. Okay. So degree. We need to talk about what a degree is. So let's put some vocab right here. Degree. A degree, we're going to say the degree of a term is the sum, S-U-M. Do we remember what sum means? Sum means to add. Okay. The degree of a term is the sum of its exponents. Or you can say powers, right? Those words are interchangeable. So the degree of a term is the sum of its powers. So we're going to be practicing that. So we got to look at the degree of a term in order to be able to name it. The degree tells us whether it's constant, quadratic, etc. Okay. And then how many terms the polynomial has is also part of its name. So it's almost like it has a first name and a last name, and we're going to be naming them today. Okay. So let's just jump right in here. By the way, when you have, I'll mention this again when we get there, but when you have a polynomial with several terms, the term you're going to look at is the term with the highest degree. Term, I want you to just add this to your notes and we'll make sense of it in a second. Term with highest degree. Okay. Okay. So number 1 here, we have 5x cubed minus 8x squared. 5x cubed minus 8x squared. Some of you are like, can we put those together? No, that's combining like terms. We can only combine things that have the same variable, which they do, but the variable has to be raised to the same power. That should sound a little familiar, okay? Anyway, so we're not combining them here. We're really looking at 2 things. We want to know the degree of it and how many terms it has. So let's make some notes to ourselves. Degree. So for the degree, you look at the term, and there's 2 terms here, by the way. 5x cubed is a term, negative 8x squared is a term, okay? But you look at the term that has the highest power, the highest exponent. This first term has a degree of 2, or a power of, sorry, I said 2, but I meant 3. This first one has a degree of 3 because its power is cubed, 3. The second term has a power of 2, which means its degree is 2, okay? But we name polynomials off of the degree of, off of the term that has the highest degree. So that would be this one. So its degree is 3, okay? All right, now we count up really quickly how many terms it has. I already said it. It has 2 terms. So let's make note of that, 2 terms. And these things are needed for us to be able to actually write its name. So its name is, well, let's go to 3 in our degree chart. It's a cubic. And then it has 2 terms, binomial. Okay, its degree is 3 and it's 2 terms. It's called a cubic binomial. So that's how you're using this chart today. Okay, let's try another one. Negative 10x squared plus 3x minus 4. Okay, so we're gonna look at the degree and we're also gonna find how many terms it has. Terms to me is pretty easy to identify. And in fact, my eyes kind of do that first for me before I even look at the degree. Like here in this first one we did, I see this as a term and this as a term. Terms are separated by plus and minus signs. That's how my eyes view it. And that is a true statement math-wise. Terms are separated by plus and minus signs, okay? So here you can see that you have this addition sign and this subtraction sign. So it actually has 3 terms. 1, 2, 3. So I'm gonna write that right here, 3 terms. Okay. Now for the degree, you want to focus on the term that has the highest exponent. This one right here doesn't even have an exponent on it. I mean, 4 itself has a secret power of 1. We just got done talking about that. But degree is based off of the power on the variable. And in fact, that might be another thing we want to add. Look at power on variable. Okay, so you're looking at the power on the variable. This 4 doesn't even have a variable, okay? This 3x has a variable, its power is 1. And this term right here has a variable and its power is 2. Therefore, this is the term with the highest degree, and that's what we name it off of. So we would say that this whole polynomial has a degree of 2, okay? So now those are the 2 pieces we need. So we go to our chart. A degree of 2 means it's quadratic. And it's 3 terms, so that's called a trinomial. Okay, do a few more. Okay, number 3. 10x to the 4th, y to the 8th. Notice how that's all shoved together. And we've learned in my class, when you have numbers and variables and more variables shoved together, they're all being multiplied, right? But they are together in 1 term. This is 1 term all together. Because remember, terms are separated by plus and minus signs. There's no plus and minus signs here. So really, this is all 1 term. Okay. For its degree, this is where things get a little bit weird, okay? Do you notice how this term has a couple powers? The x has a power of 4, the y has a power of 8. And since this is a 1 term altogether, this is called a monomial, by the way. If you look at your chart, something with 1 term is called a monomial. When we're trying to figure out the degree on a term like this that has several variables, you end up adding the powers, okay? since these are together in one term, and it's only because they're together in one term, you actually end up adding the powers. So you add 4 plus 8, and you get a degree of 12. Okay. We'll practice that. Don't worry. It takes some getting used to. I understand. Okay. So this has a degree of 12. It's one term. We know it's a monomial, but what type of monomial? If it has a degree of 12, look, our chart doesn't even have 12. So we think of this. Well, if it's any number higher than 4, we just call it that degree. So this would be the 12th, a 12th degree monomial. That is its name. Okay. I would like you to try this last one without me. So as soon as you write it down, I want you to figure out the degree, figure out how many terms, and try to name it. Hit play when you're ready. So here's number 4. 2x to the 4th minus 3x cubed plus x squared plus 8x minus 10. Figure out the degree, count how many terms, and then name it. Hit play when you're ready. Okay, I'm going to do terms first just because I want to. I see one here, 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 here. 1, 2, 3, 4, 5 terms. Okay, terms are separated by plus and minus signs. All right, for its degree, I'm looking at the term that has the highest exponent, which is this, the 2x to the 4th power. Its total degree is 4 because it has the exponent of 4. Okay, we didn't have to add any powers there because this is not a monomial. So this is the term with the highest degree, and it only has one variable in it. So we just have 4 as the power. Okay, and then to name it, you look at a degree of 4, that's a quartic. And then 5 terms. Anything with 4 or more terms, we just call it a polynomial. Okay, so this is a quartic polynomial. Okay. All right, next up, we're going to talk about writing polynomials in standard form. So this is like what I really want you to, I want you to know how to name them, but I really, really want you to know how to write things in standard form. Okay, standard form. Let's write down a little note to ourselves. The terms of a polynomial should be written. The terms of a polynomial should be written in descending, D-E-S-C-E-N-D-I-N-G, written in descending order based off of their degree. So you can think of it as their power. Terms of a polynomial should be written in descending order. That means highest to lowest. And in fact, I think that's a good thing to put in here. You're always going to put the term with the highest power on the left. Highest power. Some more vocabulary for you is the term with the highest power is called the leading term. Okay, so it's the one that's the leader, if you want to think of it. And then you're going to go all the way down to the term that has the lowest power or possibly no power at all. So like this little 4 minus 4 that we had, that's called a constant, doesn't even have a variable on it. Constants are always going to go at the end because they don't have a power. They don't have a variable which has a power. So therefore they don't have a degree. Okay. So highest power to lowest power, that's really what standard form means. So let's practice that. So we're going to write a polynomial nice and big here, and we're going to really kind of dissect it so we can talk about some vocab pieces. So here we go. We have an 18x minus 5 plus 10x cubed minus 4x squared. Okay, so we are focused on writing this in standard form, highest degree to lowest degree, okay? Or highest power to lowest power. And they'll maybe put this on there. Lowest power is going to be your constant, if there is one. Something without a variable on it, it's going to be at the end, okay? Like this guy, he doesn't have a variable on it. He's going to end up at the way end. Anyways, I'm getting ahead of myself. Let's talk about just the 18x. Let's focus on that because that's one term in itself, 18x, okay? Let's talk about its degree. It has a degree of, and you be careful, you look at the power on the variable. I see an x there. I don't see an exponent. What is the secret exponent? 1. So this term right here has a degree of 1. Now let's look at the -5. And yes, this is a -5, not a 5. Remember, we keep the sign that's in front of it, okay? So you can say this as -5 when you're reading it, 18x minus 5. But really, that 5 is negative, okay? This -5 here, that's your constant. And that is because there's no variable attached to it. It technically has a degree of 0. Because if you imagine, you could write an x next to it, but it would be to the power of 0 because x to the power of 0 is 1. And 1 times -5 is -5, okay? So this has a degree of 0, therefore it's your constant, okay? 10x cubed, it has a degree of, hopefully you can see it, 10x cubed has a degree of 3 because the power on that term is 3. And then -4x squared has a degree of 2. Okay, so if we're trying to write this in standard form, we have to put the term with the highest degree on the left. That's our leading term. So your leading term here is this 10x cubed. Notice it's positive, so I'm just going to leave it without a plus because it's not needed, okay? The next highest power or degree is this degree of 2. Now you can be careful. This is not 4x squared, it's -4x squared, right? So when you bring it down, you got to show that little minus in front of it. And then we have 2 left, a degree of 1 or a constant. Obviously this degree of 1 is going to come next. I hope that's obvious, sorry. Didn't mean to say it like that, okay? And then this constant always goes at the end, so -5. Okay, I always double check that I kept their signs. 10x cubed is positive, the 4x squared was negative, 18x was positive, the 5 was negative, okay? So this would be your final answer here written in standard form, all right? Last little part of our notes, and we'll practice this again in Zoom class tomorrow. I want to briefly remind you how to add and subtract polynomials. So we're going to say adding and subtracting polynomials. I say remind because we have done this before. I just didn't say, hey, let's add and subtract polynomials. What I said is combine like terms. That's something we did trimester 1 this year, combining like terms. So you're going to remind yourself, same as combining like terms. Okay. And we do want to be careful on this. You can only combine terms that have the same variable, but that variable has to be raised to the same power. Okay, so let's write that. You can only combine terms that have the same variable raised to the same power. Okay. Okay. So we are going to just do 2 of these questions because once again, we'll practice more on Zoom. Okay. So we're going to combine like terms, and then we're going to always write our answer in standard form. You always need to make sure your final answer is written in standard form. Highest degree to lowest degree, highest power to lowest power, however you want to think of it. Okay. So, oh, and then we're going to name it because why not? We know how to name it now. We'll refer back to our charts from the previous page. So number 1, we have 5x minus 2 minus 8x minus x to the 4th plus 10. Okay. I know that's a lot, but you're fine. You can handle it. Okay, lots of terms here. The first thing we want to do is see if we can add or subtract any of them. If we can combine any like terms. I always just start with the one on the left. So a 5x. Can 5x go with any of these guys? Well, I'm first looking for if they have the same variable. This -2 doesn't have a variable. The -8x, right? 5x can be combined with -8x. Can it be combined with the -x to the 4th? No. It has the same variable, not raised to the same power though. So only these 2 guys are going to be put together. 5x minus 8x, 5 minus 8 is -3. So that would be -3x. Now I'm still going to see if there's any more like terms. This -2 is a constant. It does not have a variable attached. Constants can be combined with other constants like this 10. So +2 and I said that backwards. -2 and +10 can be put together. -2 plus 10 is +8. Okay. And then this -x to the 4th, it doesn't have any like terms with it. So we just drop it down. Okay. So step 1, we combine like terms. Now we need to write that in standard form. The term with the highest power comes out front. That would be this guy. Keep in mind, this is a -x to the 4th. The next highest power would be the -3x. And your constant, which does not have a variable, so it does not have a degree, goes at the back. So there's your standard form. Okay. The last thing I want to do is I want you to name it. So pause the video, flip back to your little charts from the previous page, and you're gonna name it. Okay. So these are named after their degree and their number of terms. The highest degree here was this 4th power. So that is called a quartic. And then the second part, so that's its like first name. Its last name is named after how many terms it has, which is 3. 1, 2, 3. So this is a trinomial. Okay. I want you to try out number 2, all these steps on your own. So combine your like terms, rearrange it into standard form, and then name it. Number 2. 7x squared plus 8y squared plus y squared minus 5 plus 10x. Okay. All right. So do all those three things and hit play when you're ready. So for combining like terms, I'm going to just start left to right. X squared, 7x squared. X squareds can only be combined with x squareds. So I see some y squared, not the same variable. I see an x, doesn't have the same power. So I'm just going to drop that guy down because he did not combine with anybody. Okay. Y squareds can go with y squareds, right? Okay. So this is 8y squared. This is like 1y squared. So you add the coefficients together. 8 plus 1 is 9. So that's positive or plus 9y squared. -5 doesn't have a variable on it, and there's no other constants. So I'm just going to drop it down. The 10x can't be combined with anything. So I'm going to drop that down. Okay. So step 1, we combine like terms. Now we need to make sure that it's in standard form, highest power to lowest power. The thing is, these two guys right here, they have the same power. So when you have terms that kind of tie, like they have the same amount of power, then what you do is you go off of the alphabet. Which variable comes first in the alphabet? X, right? X, Y, Z. So 7x squared gets listed first, then the 9y squared, and then what's next? The 10x. And then the -5. Okay, so that's your standard form. Last thing, naming it. Okay, so the degree of this whole polynomial is 2, and that's because its leading term right here has a degree of 2. Degree of 2 is quadratic. Okay, once again, we're getting this from the charts on the previous page. And it has 1, 2, 3, 4 terms. 4 more terms is just a polynomial. Quadratic polynomial. Okay, so that's going to be it for today. You're going to practice on delta rearranging in standard form because I think that's super important. And then we'll just kind of practice the naming of them throughout this whole unit. Okay. All right. Thanks, guys. See ya.